right. Well, welcome. This is the camera and equatorial mount workshop, following up on Chris's previous workshop month or two ago. What is it? It's September, end of September. So in this workshop, we're going to talk, obviously about camera and equatorial mount, and basically astrophotography with just that. So kind of a minimalistic setup, your step beyond static tripod and camera. We've got some example mounts and setups over here we can talk through. I'm okay with interruptions. If you have questions, raise your hand. I've got a microphone here because we are recording. There were some people who are interested in seeing this that couldn't attend. So we'll try to capture the question through the mic, or I can restate it if you don't want to hold a microphone. So just real quick, astrophotography is, we got a definition or whatever, but you don't know, we were taking pictures of celestial objects and phenomena. So your, solar, lunar, planetary, deep sky, asteroids, anything interesting. Interesting bit about astrophotography. I think this reference is probably on, most of my references are probably Wikipedia, but the first known astronomical photograph was taken in 1839, which is pretty cool. Almost 200 years ago now. Getting close. Get the right lights. Which one? Are good? All right. Easier to see. Excellent. And my clicker, of course, doesn't work. Okay. So just to kind of like set goals, what do we want to do in this workshop? We're talking about taking a picture of a deep sky object. I'm not talking about planetary, solar, lunar. Those are different beasts. You're taking video, and the processing and stuff is very different. Maybe interesting to have a workshop on that sometime, led by somebody other than me, because I've dabbled, but I am definitely not an expert on that. And the reason why, if you throw a camera on a tripod, longer focal length, this is what you're going to see if you don't have some kind of tracking. So I'll have, in the bottom right, I've got this little icon. That's when my reminder that I've got some little bit of a story to tell. So if I don't tell a story, you can ask me to, because I don't have any presenter notes. I just wing it. So this was 2.5 years ago. I had just gotten into taking pictures of deep sky objects. Anybody guess what object this is? Yay, M42. Oh, damn. So the Great Orion Nebula, I forgot to put it on the slide. So this was kind of an example for myself, like comparison. I ended up building a barn door tracker, which I have here, and I'll talk about a bit more in the presentation. And I'll explain what is a barn door tracker, because it's one of the more basic equatorial mounts. But this was what does it look like if I don't use it for 30 seconds at 300 millimeters? And stuff's moving pretty fast. So, and it's because, we're rotating, the Earth's rotating. So relative to, our perception of the sky, like we see the stars move throughout the course of a night. Great example right now, if you go out at sundown, you're not going to see the Orion Nebula. But if you go there at sun up, you will. I've been for a couple walks early in the morning. I'm like, it's almost time to take your picture again. So we're going to adjust our goals, because we could take that, streaked image of deep space objects and we can call it a day, but we want to eliminate that star trailing, which is where some kind of mechanical compensation is necessary. So the equatorial mount. Come on, button. All right, so don't read this. This was the quote off of Wikipedia, and I pulled out a couple of key things. So we're rotating around an axis, so the rotational axis, to compensate for the motion of celestial objects at sidereal or sidereal time. I'm not sure the proper pronunciation, tomato, right? Which is the rate of Earth's rotation. And we do that by aligning that rotational axis with the celestial pole, either north celestial pole or south celestial pole. And in the north, we have a bright star Polaris, which is almost there. It's not actually at the north celestial pole, but aligning with that pole is, called polar alignment, and that gives you the axis of rotation, which then with the right rate of change in moving, you're then compensating for the rotation of the Earth. So for doing that, we need a camera. Got a couple of DSLRs over there and some camera lenses. We're not talking about telescopes in this workshop. You need that mount, something to compensate for Earth's rotation, and then knowledge. Like this is a little bit beyond just throwing something on a tripod and taking short exposures, which is great. Milky Way shots are amazing. But we need what I'd like to convey is like some tips and tricks, and kind of I'll get into like checklists. So the way my brain works, like I have a literal checklist I will sometimes print out and take, like if I'm doing a new equipment setup or going somewhere remote, like did I remember everything, all my filters, which I've forgotten before? Did I remember power, which thankfully I've not forgotten yet, but all the cables and all that kind of stuff. So camera, Chris covered in depth DSLRs in the last session. I'm not going to cover them in this session. I mean, if there's questions that pertain to using an equatorial mount, happy to talk through them. And there's some bits and pieces in the presentation that is specific to using an equatorial mount, because you are looking at longer exposure times. So things are a little bit different. But we're really talking about mostly the equatorial mount. This, I have it in the front here with some modifications and some tape and cardboard, because things weren't perfect. But this is a barn door tracker that I built 2.5-ish years ago. And it's been fun. I've used it a couple times since. Last time I used it was in January this year, which I'll talk a bit more later. We've got an example of the Star Adventure 2i, I believe, Chris? Is that? Yes. Yeah, which is another equatorial mount, can handle a light payload, so camera plus a lens, not a problem. You have a lot better machining than a barn door tracker, and you have a polar scope on this one, so it helps with polar alignment. And then you've got the bigger mounts. So these are two that I have. The AM5 from ZWO is reasonably new. I've got it over here with a 20mm lens on it, which I've actually used. I forgot to bring another camera to put on the back, but it's a camera lens. You just hook it on the back. And EQ6R Pro, which is kind of like the big brother of the Star Adventure, or maybe a couple generations bigger brother. I don't know. So before I get into the list here, so this picture, I love this picture. So I started playing around with Bing AI to generate some pictures for some of the slides, get some color and whatever. And like, what is this guy doing? He's got like this third arm holding a book. I don't know what that book's doing. Like this book bleeds into the ground. And it's like AI is a hoot to give a try. But so what I want, how do you set up a mount? Some of the more frustrating things I've experienced are kind of what I'll present, like some of the setup, some of how to find focus, how to find targets, and then tips on taking photographs. And then I have a bucket of general tips at the end. And hopefully, if you have questions, comments, whatever, please interrupt me and we'll take them as we go. I don't want people to forget things. All right, so real quick about my journey into astrophotography. So in 2020, my kids got a Orion XT8, so 8-inch Dobsonian. This is the scope if I'm going to dark sites and doing visual. Like this is what I bring. It's been great. It's been a lot of fun. I'm a novice to visual observing, and it's been great to use. And then my first picture, I think this was on the 21st of December, was the conjunction of Jupiter and Saturn. I just took my phone, up to the eyepiece. It's like, I got to get a picture of this because it didn't look like this through the eyepiece. It looked better. Like I didn't know the word collimation existed at the time, so it would have been better if I'd known how to get the scope set up properly. But if anybody's seen Saturn, you've seen the separation of the rings from the planet. It's like the first time. It's very special. It's very cool. So that's what got me started, and I wanted to do more. I wanted better pictures, so I built or 3D printed a generic phone holder. Found some models off of Thingiverse, which has a lot of great models if you have access to a printer. Good stuff to play with, and it just holds the phone. Ironically, that background is just what was on the phone at the time. Like that's not something I took, so but I can't go back in time and change it now. The problem with this particular one is very, very fiddly to get it set up. As you can see on the side here, you got a bunch of orange, and that's from the orange plastic. I just had a hard time getting the phone in the right place at the right angle and get the tilt out and the distance, and it's just a mess. So I designed something better because why not? So I replaced it. Was a 2-inch to 1.25-inch eyepiece holder. I replaced it with this green thing. So it's 2-inch to 1.25-inch eyepiece holder, but it's got a much higher side. So then this blue thingy can go slide on top of it. And the phone, my phone was a Pixel 4 at the time. This was modeled to get the camera on that phone at exact center of the eyepiece, and got a lot better. So had some fun with that. Realized that, hey, Earth's rotating pretty fast, and focal length of 1,200 millimeters. Like, yeah, that's not the best thing to try and do any kind of long exposure astrophotography with. So some of the limitations you also have is field rotation. So think about your scope is pointed, or optics on a tripod are pointed at a portion of the sky. It's not only moving, it's rotating as you go. So you're going to have the pictures rotating over a course of time, which can be compensated for. You can handle that in stacking. Had a lot of problems with focusing. Limited in exposure. I think this might be maybe 1 second exposure. I can't remember the details. It might be multiple pictures stacked. I didn't take great notes back then, unfortunately. Realized a shorter focal length would be easier to work with, and getting a better camera. So the phone was a good place to start, and I've used it for a couple things since, but a DSLR would be better. So I built a barn door tracker, some 2x4s and a hinge from the hardware store that was like $1.50 maybe. 3D printed this yellow ring. Unfortunately, the picture I took doesn't show, but on this little black bit, I had a watch face that had a second hand. The second hand glows in the dark. And the idea is you get that rod here at the right distance from the hinge so that every rotation is 1 minute. So trying to match the rotation of the handle to the watch face switch. Just imagine there's a watch there. And proof of concept, 2.5 minutes hand tracked. Definitely can see a lot more nebulosity. So it was a great proof of concept. I realized I don't have that great of an attention span for 2.5 minutes standing there in the cold in the early February, trying to not, fall behind or get ahead. And then as you can see, like there's all sorts of spikiness, like because I'm physically touching it, I'm vibrating it as I'm moving it. But anyway, so again, the comparison, I took a 30-second shot as well. So you can see 30 seconds untracked versus tracked. Same optics, same focus, same everything. Makes a little bit of a difference. So I built a curved rod barn door tracker, which is this black tracker in the front here. Curved rod meaning, as you can see, it's got a rod that's curved. There's like 5 different models, I think. If you go look at Wikipedia, there may be some more. It's got a gear. I don't remember when I switched it out from black to yellow. I think I needed a better print, a finer height on the print. And I can show it working later. There's a small stepper motor. It's controlled by a Raspberry Pi Pico, which was $5 when I bought it. Everything about this project, if you're interested in it, is on GitHub. It's open source. Models for the 3D print, the software, how to wire it, pictures of how I put it together, pictures of the problems I introduced while putting it together, how I fixed it, all those kinds of things. And then I believe this was something like 19 minutes total exposure time from my front yard or side yard, Bortle 6-ish. Yeah, so was very happy about the results. This, I think I was limited to 4-second exposures, maybe 5-second exposures before I started seeing star trailing. So just taking a whole lot of pictures. All right, I'm gonna dive into kind of setup of mounts, but before I do, any questions, comments? Nothing? Okay. So for setup, just kind of go through my own mental checklist of things I do, finding a good location. Is it relatively level ground or is it block street lights? Yeah, the annoying neighbor that turns their floodlights on at 12 o'clock at night to let their dog out. Is that a problem? Put your tripod out. I didn't mention it here, but leveling it. Oh, I did put leveling the mount. I probably should have put that up earlier. Oh no, that was on purpose, actually. Level the mount after you have the bulk of the weight on the tripod. I think, at least for my experience, I have a very lightweight mount. It's not designed for holding a lot of weight. So I found it was better for me to go ahead and throw everything on it before I tried to get it level. I mean, roughly level it to start with. For the larger equatorial mounts, probably want to level first, but get the mount on it. Install a counterweight if it has one. 2 of these don't. See on the Star Adventurer here, there's a counterweight. Get that guy installed. And get it roughly pointed in the right direction, north for northern hemisphere. I would then put the optics on, get your camera, get your lens, anything that's going to be physically on there as you're taking photographs, get it on there. And then balance. One thing I would caution, if you haven't thought about this, haven't set one of these up, put the counterweight as far from the mount as you can to start with. That'll make it counterweight heavy. And that means that if you let go, it's not going to swing around and crash into stuff. Make sure if you release clutches, you're holding on to it so that nothing goes in a direction you don't expect and don't want. Damaging camera mount or lenses can end a night too soon. Polar alignment, mentioned this a couple times, but there's like roughly 5 different ways. So the first one is, well, just like, that's good enough, kind of wing it. And I started off doing that with the barn door tracker. I then tried, which is not a great way to do it, just let me be clear. Like it can get you good enough for things like, we have the upcoming eclipses, solar eclipses. So you're taking a single picture, very short exposure, that will be fine. For deep sky, you need a little bit better. The next one I tried was a tube. Literally found, like, I had straws in the kitchen, like, oh, let me try a straw from the kitchen. Taped it on the side of the barn door. Tried to look through it, and it's really small. It's really hard to see through it. Like a larger tube, if you have something, would be good. Like a large straw maybe would work better. But it was better than winging it. And then added a red dot finder that you can see on it right now. Red dot finder just projects a red dot that you can use to then, like, basically what I do with this is I have it on top of Polaris and I call it good enough. As you can see on the side here, so celestial north, Polaris is a little bit off from it. And if you're doing really fine polar alignment, you'll want to look up where Polaris is relative to the celestial pole. There's apps for that. Software can do it as well, so you can get it on your phone. This is what it would look like in a polar scope. Usually, they'll have something in there like a translucent or transparent film that has a couple of key stars like the Big Dipper, Cassiopeia, Octans, and then Polaris. And then you need to know just like at what time, Polaris is at 12 o'clock or it's at 8 o'clock or 8:30 or whatever for that point in time. And that's pretty good. I did that for a while as well with the EQ6R. Right now I use software. We're not talking about software in this workshop, but is another option because you have a camera. Most cameras, you should be able to connect it over USB to a computer, and it could take pictures and analyze the stars, figure out where you're pointed, and then tell you how to adjust things. Before you would do that, you would need to focus. Now, we turn on tracking when you're focusing so that once you have a star in the field, it's not going to be moving out. Makes it a little hard because you'll want to zoom in through your live view. I assume you have live view. I tried this with a camera that didn't have live view. Doesn't work very well. Change to high ISO probably, because I think the live views tend to be tied to that. Maybe camera specific. I'm not 100% sure. Okay. Okay. And so the comment is that it does simulate what you would see when taking a picture. The higher ISOs, higher gain, you'll get basically each photon registered means more, so that the star will be brighter. They get rough focus. I've had, depending on the optics, I've tried like autofocus even on the lens. So that it might work, it might get you close, but then turn off autofocus. You don't want autofocus to be working. And then use the live view to zoom in and find focus. Sounds pretty simple, right? But it's not. The motions are very faint. So I found like go kind of out of focus in both in and out until you find kind of where the middle is. It'll be kind of purpley on one side, kind of green on the other, and just kind of split the difference. Another thing I use is, I think it's spelled or pronounced loop, but it's a jeweler's magnification tool, and it's just, I put it on the live view and just get even more magnification. So it can be frustrating. Like the live view on my Canon T2i doesn't articulate. So depending on where I'm focused, I'm like leaning over trying to see the screen. Oh, and here it is. And I've used it in anytime I'm doing manual focus. I'm like, it helps more than anything. Yes. The cameras I have a USB mini, and I think the cable is special. So USB, yeah. Okay. Okay, so you can, wonderful. That's a good idea. Okay, so for the recording, there's a Canon Live View and APT astrophotography tool can do a live view on computer, which will keep you from breaking your neck if you don't have an articulating live view screen like I do. And you could use this also, the loop on there. Yes. Anyone use backyard EOS? I've never used it myself. Yeah, some people use. Oh, okay, so it can control the focus. Okay. Okay. So it just directly controls the focus. Okay. Yeah. The lens I have on here is a Rokinon 135. It's completely manual. There is no automation. So, but I have a 20 millimeter there that does have autofocus, has motors. So that I'll have to look into that. That would be nice to do. Yeah, change all the settings on the computer. Yeah. All right, good to know. Thank you. Okay. Okay. Yeah. So there may be some hacking involved. Yeah. No hacking. I agree. Yeah. 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 Okay. Don't hack. Pay for it. People spend time and energy to do it. Yeah. Yeah. So this is just an example I had on the AM5, so the red mount there with the 20 millimeter lens. So I guess preview, we have the summer triangle is the challenge for this quarter. And so I was like, well, let me just get the whole thing in one picture. It was slightly frustrating, but still it worked. All right. Another thing you can use to focus is a Botnov mask. I've got several examples up here. This is the one I used on when I first started out, the DSLR I was using is the one there. It's Canon SL2, Canon EOS Rebel SL2. And the kit lens, I just take this guy and pop it right in there and use it to focus. And the idea is you want to get, it creates 3 lines. You want all 3 of them to meet right dead down the middle. And this animation shows that in action. I've got one for my the 8-inch Dob that I printed. And this one I've never used, but for an SCT, you just kind of lay it on the corrector plate. So if you're doing focus manually, it's a great tool. All right, framing. All right, we have difficulties framing. My house is not super light polluted. It's Bortle 6-ish, but the light pollution makes finding objects a nightmare. Also starting out, I had no idea where anything was. I could see I knew the Orion constellation, but that was about the end of it. So this picture on the screen, like visually, it's not my favorite picture I've ever taken, but the story behind it is kind of interesting. I had taken I showed the earlier picture of the Orion Nebula, and I was like, oh, the Rosette Nebula is nearby. I'm going to go take a picture of that. That'll be fine. It took me over an hour to find it in the camera. Oops. You can only see the stars. I didn't know anything. I don't know the major, like the constellations around Orion, so I had to go find that, learn about star hopping and how to move from one star to another to find where you are. So making sure focus is good is really important. Use software like Stellarium, or if you have star charts to be able to find where objects are relative to each other. I ended up using that 8-inch Dob to find, at the core there's a star cluster called the HARP cluster. So I ended up finding the HARP cluster with the Dobsonian. I was like, I knew where it was in the sky because I could, see where it was. It only took me 20 minutes from there to get it into the camera. It was a frustrating, long, and cold night. We ended up using short exposures on the camera, like 2 to 5 seconds, just to see the stars, because the light pollution, it was just couldn't see visually and couldn't see them through the live view. And I think the other thing is, as part of the astronomy club, if you have questions about how to find something, you're at an observing event, either outreach or RAC comms or whatever, like just ask for help. A lot of people will, one, love to share views through telescopes, but also give tips on how to find objects and recommendations on objects you might want to take pictures of. Mike.
Push the ISO up as high as possible.
Push the ISO. Yeah.
It's really noisy, but it would help us make sure that we had whatever we wanted kind of centered, and then we would, from that point, bring the ISO back down.
Yeah. Yeah, that's a good point. So for the recording, so bump the ISO up to ridiculous levels, and it'll help you find the target, find more stars so that you can find the target, and then drop it down when you finally get to taking your actual pictures. So it was with this picture where I realized that the camera I was using was kind of not going to work for taking pictures of nebula. So that was the other thing I learned. A lot of DSLRs, they have a filter that cuts out light, and most of them are close to, if not cutting out before, hydrogen alpha, which is unfortunate. You can get them modified. Got a Canon T2i that was modified, and it still has a UV IR cut filter in it, which is important for the star bloating. If you don't have UV IR cut, stars will look bloated and large. But taking out the hydrogen alpha, allowing the hydrogen alpha light to come through is really nice. Okay. So on taking pictures, recommendations or tips is basically use raw format on your camera always, because you want all the raw data for processing. The other half of this story of taking pictures with deep sky objects on a mount is the processing, which we're not going to get into here. That's something I think we're all still learning over time. But use the raw format. Disable any noise cancellation or image stabilization or anything that might fiddle with that raw data that's set on the camera. And disable autofocus unless you have the software we mentioned earlier, something that could control the focus motor, or maybe you need autofocus on for that. I don't know. Use manual mode, set it to bulb, which depends. So cameras will allow you to go to 30 seconds. Bulb is basically you have to have, either hold the button down or you have something like an intervalometer, which I will talk about in a little bit, to hold it for you, or software holds it basically by saying start an exposure and then tells it when to stop. Check what the optimal settings will be. So we talked about raising the ISO so that you could see stars, makes the image noisy. There's ways you can just look up kind of what the sensor will be if it's a common camera, or you can do the analysis yourself. I'll talk about that in a little bit. And then for lenses where you can change the focal ratio, play around with that to see what you like. So for example, that earlier picture I showed of the summer triangle, the 20 millimeter lens I took it with could do f1.4, which is really fast. The stars in the corner look like little, birds. They're all messed up. So I ended up shooting it at f2.8. There's a little bit of elongation still, but it was good enough. And I ended up cropping it out for other reasons. But find that focal ratio that you like. Because the faster you go, it means the more light you're collecting over a period of time. So it can be beneficial to go with a faster focal ratio, but there's trade-offs. Okay. Why do we need to think about the ISO? So the lower your ISO is, the higher the read noise will be, but the higher the bit depth. Bit depth gives you contrast. And we're taking pictures of really faint stuff, and it's pretty close to background noise. So the more contrast you have, generally the better. But you have that read noise to worry about. So read noise is going to be, if you've taken any pictures like this, you might see some color distortions in the background sky. It looks, red or green or kind of mottled. If you go with higher ISOs, you get that lower read noise, but you lower the bit depth. So you find the sweet spot. And for every electron, every photon that's coming in and hitting the sensor, you need to look at the analog to digital units, or ADUs. How many of those photons, when they hit a sensor, registers? Don't know that there's like a hard and fast rule about this. I'd look for generally like a 1-to-1, like one electron is one registered ADU, but it can depend on the noise. I've used photons to photos.net. It's got lots and lots of cameras on there, lots of different graphs that are kind of a nightmare to figure out how to read. But it's worth doing if you don't want to do the analysis yourself or can't do it yourself. SharpCap has sensor analysis though that you could do. I'm pretty sure it's free for the sensor analysis. If not, you should. SharpCap's another one of those tools that's really good. I don't use it a whole lot anymore, but I really like their polar alignment routine. So my Canon T2i, this is it from SharpCap. I just want to show what it looks like. So you can see the read noise with the red coming down. So it's really high at a low gain or ISO. So lower the gain or ISO, the higher the noise, so it tapers. But then also the dynamic range, as the gain here gets higher, the dynamic range gets lower. So for example, in this one, I found, okay, the read noise is half at 200, it's half of 100. Don't really have much of an impact on the dynamic range. The ADU, electron to ADU is close to that one sweet spot. So I run at ISO 200 for this camera. This is that same camera on photons to photos as an example of the ISO versus the read noise in this one. So you see as the ISO goes up, it's showing also that read noise goes down. So you can use this as a resource for cameras you don't want to run the sensor analysis for. And then ISO versus dynamic range. Like as that ISO goes up, the dynamic range drops. But there's a bit of almost a plateau at the top. So it's not so bad. And then it goes down a good bit. If you look at like cooled astrophotography cameras, they tend to have a different characteristic where there's a high conversion gain in some of them. And I've heard there's even like there's a new mode, so a third mode that some of them have, which I don't really know much about yet. But this is an example from a ASI 533 MC Pro. You can see higher read noise, and then at one point it just drops down, and you don't see much of a change in the gain graph there. So where was it? 100, I think, is the sweet spot for this camera where the read noise drops, and the dynamic range actually goes up a little bit from lower gains. So I had one of these. I ran it at 101 very specifically, only because SharpCap said to. So a lot of people will go 101 just in case, just to make sure it gets into the right mode. But you can, Chris, yes.
Would you say 100 is for that?
Yes, for this sensor, 100 is unity gain. So unity gain being you have one photon or electron registering as one ADU. Not all cameras are going to have a unity gain. Yeah, I mean it's pretty close. The marketing stuff says 100. As I said, this is the sensor for the camera I had. I have the ASI 2600 mm, and it doesn't have a unity gain. You could drop the ISO or the gain to 0, and it's less than 1 electron per ADU still. So in that one, it's more about the read noise and dynamic range, because it has a similar graph. At 100, it drops. Other cameras have different places where it drops, so it's specific to the sensor and the camera and how it's been manufactured. But I just want to throw this up there for comparison from the DSLR. If you're looking at making that leap, be something to consider. Okay. Any other comments or questions? All right. So back to like star trackers or the barn door tracker or whatever, like how long of an exposure should you do? There's basically, there may be more if you have other things that you would say are limiting factors, but there's 3 that I look at is, am I seeing star elongation? Is the tracking off and I'm starting to see the stars look kind of eggy? Am I seeing tracking errors, meaning not even just the elongation, but is it windy, causing things to move? Is it my barn door tracker where the gears don't mesh perfectly and I have to throw away half of the exposures I take? Like that literally happen. And then the star saturation. Are you, well, maybe you don't care about the color of your really bright stars, so this may be less like what's important to you in the picture, but one of the things I look at is, are the cores of the stars, are those pixels getting saturated? When you get saturated, it means it just looks white. You lose the color data because once it hits saturation, any data that comes in is lost. So try to keep it below saturation for my goals. I want to see the nice, pretty colors. It's really cool to see the differences in star colors in pictures. Any other limiting factors anybody would throw in there? So just some thoughts on like how do you find those factors? So for star elongation, take a longer exposure than I probably think I can or should do. Review the stars on the live view, see if they're elongated, zoom in and adjust, shorten to where I find the sweet spot. I found with this particular barn door tracker, I mentioned my earlier Orion and Rosette Nebula images. I was taking like 4-second exposures. That's at 300 millimeter focal length. This lens is 135 millimeters, so shorter by a long amount, a good amount, and I can expose longer. So I've used 15-second exposures with that barn door tracker. Yes.
I recall there being the 500 rule.
500 rule, yeah. So the 500 rule, I think Chris went over that in the last presentation. That's more for static tripod setup. Right. I mean, yeah. So when you're tracking, that one kind of goes out. So the 500 rule is basically how long can you expose without tracking before you see elongation of stars, and it has to do with the size of your pixels and where you're. There's a couple different calculators I've used. There's the really simple 500 rule, which I think I can't remember exact math, but there's a more advanced one that takes into account the declination. So the declination 0 being celestial equator. I don't know what the right term is off the top of my head. And 90 would be like the poles, minus 90 for South Pole. Because how far you are from the pole affects how much movement you'll see in the sky. So if you point at Polaris, things aren't moving very fast, so you could expose longer. But yeah, it doesn't really factor in for this. When I used the AM5 for the summer triangle image at 20 millimeter focal length, it's a very wide field. That was 75-second exposures. I think I probably should have gone shorter for star saturation, but yeah, trade-offs. For star saturation, this one, This one can take a little bit more time and it requires, I would do it at the, post in the processing phase. So like first night you're out, I wouldn't sweat it. I would take a couple of different exposures just to have some sample exposures, take it back to a computer the next day or week or whatever, and take a look at the pixels in your stars, the ones that are really bright, if you care. And just see, are they at saturation? And I mentioned here taking a baseline so you know what saturation is. And that might seem weird, and you're like, well, that's just the maximum value. I thought so too until literally like 2 weeks ago. The T2i I have, when it takes a picture, saturation on a scale of 0 to being no data, 1 being completely saturated, which is what the typically see in the software I use. For this particular camera sensor, it's saturated at 0.2334. So not always 100%. So that one threw me for a loop. But since I figured that out, like it makes sense. Like I can do automatic flat exposure calculations in software now because I know I shouldn't target 50%, so I can target 12%. So, but yeah, I wouldn't worry too much about it. And one of the things I do a lot of times with new setups is I'll take a bunch of different pictures with different settings and then set up to like whatever I think is going to be the best and just go for the night and then do the analysis later to see for the next night, what would I do different? For taking a bunch of different pictures, so we're taking multiple exposures over a long period of time because we want to process them. I've mentioned the intervalometer. This thing, it's really simple. One I got on Amazon, I can't remember, it was like 20 bucks maybe. It plugs into a port on the camera and you can configure how long to delay until the image taking starts, how long of an exposure, how long of a delay between exposures, and how many pictures to take. And then on mine is whether or not to beep every time it takes a picture, which is off. It's really annoying. So the odd thing, so I don't know if this is camera specific, but one thing to throw out there is I found that do bench testing during the day, one, because that saves you time at night. Because for this intervalometer and for my cameras, I found if I tried to have a short, like 1 second or no seconds between each exposure, it didn't work. I had to have 4 seconds at least. So test that during the day, on inside without the mosquitoes and cold. Yeah, it's weird. Which eats into total time taking pictures, but if it's not going to take any pictures if I don't set it properly, then it is what it is. There's other options besides an external hardware device like the intervalometer. There's Magic Lantern, which works for Canon cameras. I've not used it before. I know Chris has it on his camera up here and has used it for some solar photography. Some cameras have built-in functionality now to do that. And then, of course, we'll talk about like the next level, probably the next workshop will be like controlling it with software would be another option. All right. So with my barn door tracker, Canon T2i, which is HA modified, this Rokinon 135mm lens and an intervalometer, I was doing a presentation at Astronomy Days earlier this year about astrophotography without a tracker. So I wanted to get some pictures with the barn door tracker to throw in there after 2 years of learning how to do stuff better. So I took some pictures in my backyard. As I mentioned, I literally threw away half of the exposures because stars would streak because the gears would, I guess, jam or whatever. I almost motivated to make it a belt drive system or belt driven system, but not that motivated. The Pleiades or M45, so 15-second exposure is what I could do. This is a total of 25 minutes, 100 pictures I got to keep. I think this one I didn't have to throw away half of them. It might have been only 40%, but still it hurts. Every one of them hurts. Witch Head Nebula, which I want to go back to, almost half an hour. This one, I've seen some other pictures from members of the club where there's just a ton of hydrogen alpha in this region. Should be pretty neat. But and then Orion, the belt, which is over here, and I'm sorry, the belt here and the sword here. So we've got Flame Nebula, Horsehead Nebula, Running Man, and Great Orion Nebula. Surprised that Horsehead turned out as well as it did for only 10.5 minutes, but yes, sir.
This a small period of time in between exposure, you can tell that is the sensor heating up over time.
Okay, question. If I wait between exposures, can I manage the heating of the sensor by waiting between them? No, no. What I did some testing, bench testing in my study, which is, you know, at the time was a warmer environment. But what I found was with the intervalometer, I actually wanted it to get to a steady state. And I think it took an hour for the sensor to stabilize temperatures if it was taking exposures regularly. The reason why I did that was to understand, like, when would be the ideal time to take darks, like the darks that would be for the bulk of the pictures that I was taking, or flats or whatever, so that everything is at the same temperature. I've stopped caring about that. It doesn't seem to matter too much. I'm actually taking flats and darks before my session now. And I may stop taking darks with the T2i and just use a, you know, quote, library, like the latest dark I happen to take, because it takes too much time. And oh, sure. So I don't have anything to get into the calibration frames, but that is something we need to talk through. So when you take pictures, there's the noise that's generated by the camera. So the question was, what is a dark? Noise generated by the camera, and noise generated when you read the data off of the sensor. And there's also potentially, depending on your camera, there can be glowing artifacts called amp glow on the sensor that shows up on every single picture you take. You take what's called a dark, where you close off all light sources from the sensor, and you take an exposure with no light, typically for the same duration as the pictures you're taking for lights, and then you use that to calibrate out. Yeah. Yep. Yeah. Yeah. And then flats, I mentioned, is with lenses and telescopes, there's always, well, not always, but a lot of times there's light fall off or vignetting in the image. So the Newtonian I like to use, that's right in the middle, and then it just kind of gets dimmer towards the edges. And if you look at a curve, it's kind of like, think about the lens, like it's thicker in the middle. And I don't know, that's the way my brain correlates it, like the center of the image is brighter. And that is used not to subtract out noise, but to do, I think it divides it or something, so that it normalizes the data across the entire field, and you get a nice flat image. So, and it can correct for the flats are, I think, really important, as it'll correct for any dust particles that might be in your optical train. So they'll show up as like a big splotch of, you know, something that's dimmer. And with the flats, if they're done right and they didn't move around during the night, they'll get subtracted out. Okay. Bonus material. So just some tips and tricks. So we're just under an hour. Couple things to think of, like removing the camera strap, recommend. So it's not going to bind on something. The camera strap's not going to blow in the wind. You're not going to accidentally snag it with your elbow as you walk by. And then cover the optical viewfinder. That just is another potential path for light to come in. I don't know how well that's closed off, but yeah. You want to tell a story in the mic?
So yeah, covering up the cover optical viewfinder. Here's an example of why that's important because it happened to me one time and I just really couldn't figure out what was going on. My in-laws, we were over on at their place and they have a pretty open sky. It's cold. And so they had a fire going. They were all gathered around it having beer. Whereas me had that kind of setup that you're seeing up there. I was a ways away, I would say somewhere between 50 to 100 feet away. And just because mainly it was just like, I don't want the smoke messing up my pictures. And then every time I looked at a picture, there was like this weird orange gradient on it. And I was like, I wonder. And so I just took some electrical tape, covered up the viewfinder on it. Yep, it was gone. It was the fire that was doing that the whole time. So yeah, it can happen. I mean, if you're dark all the way around, not that big of a deal, but yeah, you can see how something handy can creep its way in there and really, well, screw up the photo.
Yeah, that's interesting. Good. Thanks, Chris. So speaking of that, cover up all the bright lights. You're not going to cover up campfire probably, but I'll put tape over. Like most of my rigs are more complicated than this. They have like LEDs on various things that are glowing, and I'll throw a couple layers of opaque tape if I want to see what it is, or like electrical tape is great because it doesn't leave residue. Harder to cut out in the field, so bring scissors. But yeah.
It's an issue if your camera is based on a prism-based optical. A lot of cameras now have their own screen in the optical, right? So you don't need to cover that.
That's a good point.
Right?
Yeah.
Yeah. Well, yeah. Is there non-mirrorless cameras that have? Okay.
It sounds like.
Yeah, but I mean, don't knock yourself out if it is.
If it's a screen, don't have to worry about it. Yeah, that sounds fancy. I don't have a fancy camera.
Yeah, I mean, I thought that's what's everyone's using.
I don't have any new cameras though. That's a good point though. Well, I mentioned here example power bank. So I've got a battery down there. Battery down there that has some lights. They're not bad, but things to think about. I've mentioned this a couple times. I think test everything you can in the daytime. Make sure you understand how to, get everything connected up and balanced, and your power situation works if you have power going to something. You understand how if you're doing calibration frames, how you're going to do those calibration frames. Yeah. So the lower your tripod is, the more stable it's going to be. Mine, this gray one in the front with the barn door, is the weight rating for that is really, really small. Like I'm abusing it every time I put something on it. The lower it is, the better, because I don't have it all the way extended, but the legs get really thin at the bottom. So it's also, you're going to get out of the wind if you have a wind causing your mount to move. So lower is better, but I'll remind you, if you are focusing through the viewfinder, that puts the viewfinder lower, which can be a challenge. I tape the balance points on anything I can, because I tend to, use the same setup over and over, and I don't want to have to rebalance it every time. I can just slap it on, line up 2 marks, and good to go. I think also just a shout out for tape. If you're going somewhere remote, take tape with you. It's great for, holding. I have I'm sure a tip later here, but hand warmers are good for controlling dew. I just tape them on to the lens. My first telescope I ordered dew straps, and it took 3 months or something for them to come in. So my wife happened to have hand warmers from a trip that we had done in January. And I was like, oh, I've heard those might work, and just slapped them on my telescope, both the guide scope and the main scope every night till I got the dew straps. Worked great. I use them on eyepieces too for visual. I tape the focus once I get it set, just to make sure it doesn't move. I use either painter's tape for this, because you're going to end up taking that off within the night, or gaffer tape. You could use electrical tape. Oh, with the zoom as well. Yes. Yes, absolutely. Great point. I mentioned the hand warmers. So for dew control, they're great. They're reasonably cheap. If you're ever at a outreach, I try to keep hand warmers with me. If you need them, let me know. Right. Would be pretty large hand warmer, though, or back warmer. Yes, for the back. Okay, so that might be interesting. I have my wife doesn't like being cold. She's got some foot warmers too. You're supposed to slide in your shoes, which I haven't broken out to try, but they're longer. We talked a bit about calibration frames. I think they're better to have them and not use them than to not have them and need them. The darks, depending on if you care a lot about the temperature, you can get away with taking darks later. The problem with flats is if you swap out lenses, you're potentially moving dust around or introducing new dust. So that won't get calibrated out. So taking the flats before you change any of the optical train, whether it's a camera lens or a telescope, is recommended. Not going to talk much about this, but just something to think about. How are you organizing your files? I assume you want to take pictures of more than one thing. Probably going to be doing it more than one night. How do you manage all that? I've got a write-up that I'm pretty sure I've shared on the Discord site, and I can bring it up and share it later. But it's more than I want to put on the screen here. It's a big wall of text, but something to think about, strategy early on. And I mentioned this before, just kind of a bracketing strategy. Like if you don't know what the optimal exposure settings are, take some of the permutations that you think might be good, try them all out on an actual target, pick one of them, do your imaging for the night, and then review those various options that you thought might work. So you can see, okay, next night I'm going to drop the ISO down or take a longer exposure or whatever. That's it. Thanks. Any other questions, comments? Yeah. Oh yeah, put the hand warmer on before you need them. Yeah. Yes. Yes. Yeah. I haven't had any problems with thermals, but I try to keep them closer to where the glass is, but some of them are, yeah. Or just maybe hand spray.
All right, so I do have an Equatorial mount that I'm currently using for astrophotography. The one thing I don't fully understand is the terminology flip. Basically, you reach a certain point in the zenith with the and I've heard you can adjust that. There's can you give a definition of what flip really is?
Flip would be a meridian flip. So as we're tracking an object that's in the west, it's moving from west to east. When it hits zenith, you're now going, if you go past zenith, you're potentially going to have your optical train, camera, your lens, any other equipment that might be on there, coming in contact with the mount. the tripod or something else. So meridian flip is where it hits a certain point and it will move the camera over to the other side and then track down.
So if that occurs, is there any recovery as far as your?
What do you mean? If you do hit something?
Yes. Well, don't hit anything, but does.
Oh, so the software will, okay, so there's a couple things there. So when you do a meridian flip, I'm not sure actually, with the Star Adventure doesn't do automated flips. So that's one thing. If you have automation that can do the meridian flip, you probably have automation that can recenter your target. So you'd be like, I use Nina for my imaging. Whenever I do a meridian flip, it will take a picture, plate solve, and say, oh, you're off by whatever, and then adjust and to center the object again. And then it's just your pictures are rotated. And then when you do the processing, the star alignment will just get them all in the right position. So it'll be fine. Yeah.
I didn't quite trust the software, but I think I'll do that next time.
Yeah, Cyril and DSS will do that just fine. Yeah. Okay. Anything else?
Oh, the other thing I was thinking about, at what point should you go with a guide scope?
Oh, guide scope. The benefit of a guide scope and a camera would be that you could count for polar alignment inaccuracies and some tracking errors. So the longer your focal length, the more important it becomes. So I guess it's a question of like, are you happy with how long your exposures are? One of the things to consider with very short exposures is you have a lot of files. Each of those files is a certain size, and that adds up really fast if they're 4-second exposures. So you're into a data management nightmare. So that's one thing. And I think for myself, I use guide scopes for even when I use that Rokinon, just because I can, and I don't have to think about whether I'm gonna see issues with, unless there's some like heavy winds or something crazy. The scope I'm using right now is a C8 with a reducer, so the focal length is about 1300 millimeters. Guide scope, very important. 6-inch SCT, yeah. Yeah. Right. Yeah. So these would be great topics, I think, for the next workshop. We'll start talking about more of the automation. Right, Chris? Is that the plan?
Yeah. So
Here, you want? Thank you.
Yeah, so that's the plan. Yeah, the first workshop, we basically laid out the foundation of astrophotography in general. We talked a little bit about processing, a little too much about processing. Yeah, and that was just a camera on a tripod, and what it's all about to, what it entails to take images of the night sky. Whereas here, when we in this workshop, all we did is we just took the last workshop, and the only thing that we added on was the equatorial tracking, and everything else is the same: camera, lens, a tripod. There you go. So 1 and 2. So the third one, the final one, will be finally astrophotography with a telescope. So everything started on a tripod and a camera. Then you had equatorial tracking and a camera. Then you now we're going to use equatorial tracking, telescope, and a camera. And I don't know, maybe somewhere down the way we'll actually get into the nightmare talk of doing a workshop about processing, which yeah, that's going to be, don't know how short that one's going to be, but yeah. So there you go. So yeah, the third one, we're just going to add a telescope to mix.
Yep. All right. Cool. I guess that's a wrap then. Thanks, everyone.